This is the subsystem presentation for the automated metadata content tagging project. Adam Batat will be handling the video processing, web development, GitHub, and TextRank. Jesse Bowers will be handling the PDF processing, LAMP server setup, T5, and web development. Alejandro Suarez will be handling the image OCR processing. The United States Navy has a lot of training documents, videos, and some of the documents contain picture files. When students are studying, it's hard for them to go through all of these documents to find the required information that they need to learn. This project is going to split out the training resources into metadata tags and also record the original position that data was found within the original document. This information we will then write into a database, so when students are studying and they need information on a topic, they can go ahead and access a website, query the information, and it'll bring them right to the correct place in the document. The approach that we're going to take is we will create a website on a LAMP server. This website will give users the capability to input a URL or a file, PDF document, or a video, and then click Process. Process will then extract the text from the video or the document. It'll assign a metadata tag to it, and then it will write that information into the database. Then, if they want to search later, it'll use SQL to do a query into the database, which will then return the URL or document link, and they can click on that using the information that was also stored in the database of the location of the information within the training material. It will automatically take them to that location. We will use a web client, which will be the website. It'll be running on the web server, and then the back end will be a LAMP server, which will also run the server and the Python that is needed and the database. The information flow will be from the website initially. So if the user submits a PDF for processing, it'll go down to the LAMP server. It'll go to the Python PDF processing app. If there's any images within that PDF, it'll access the OCR processing. That'll return that text. And then the text will be sent to T5 to summarize, back to the LAMP server, then input into the database, and then with the successful submission to the database, the user will get a successfully processed message. It's basically the same flow for video processing. They'll submit to the LAMP server. It'll go to the video processing application. For video, we're going to use TextRank because PDFs have a table of contents, but we also need to have that metadata tag for video. So that'll use TextRank instead of T5 to get the metadata. Then I'll go back to LAMPs and then into the database. And then when a user wants to search for training information, they'll also access the same website. It'll go to the LAMP server, query the database, and then return the information that is relevant to what the student is trying to learn. And then it'll also have a link where they can click on that link, and that'll take them to the internet, to the location of the original training document. Subsystem for the PDF document. Subsystem for the PDF document processing will work as follows. First, we take the PDF and convert it into a text file. Then we read that text file and look for the table of contents. Then we parse the table of contents with the page number of each option in the table of contents. The program then will loop through the rest of the document. Every time it sees something that's in the table of contents, it'll parse all that text out until it sees something that was in the next table of contents item. Then, since we have all the text and information for each section within the PDF, it'll feed that into T5, which will abstractively summarize the information and then return that. Everything is then written into a list in Python. We'll have the file name or URL. We'll have the page number where that information was found. We'll have a summary of the information, and we'll have all the original information as well. Then that'll all be written into the database. Here is an example of the original PDF miner extraction from a PDF file of the text file that is created. You can see there's lots of extra line feeds. There's also some special characters. Here is how the parsed table of contents will look. We just put a tag title to show what the title is, and then page to show what page number it's on. Additionally, you can see there are some special characters. The code will also handle parsing and removing them. This is actually the final list within Python that has just been written to a file so we can review it. We will have the file name that was processed, the page number, the metadata tag, and the full text. This information is what will be written to the database, so when users want to search for relevant training information in the future, this is all the data we will have.
Okay, so this is the subsystem for audio transcription and metadata generator for that transcription. The first thing I had to do is we will have to convert the video to a WAV file, and this is done by using the Python package MoviePy editor. Next, I used speech recognition, which is a Python package, and when using speech recognition, it only has a limit of 10 megabytes per call, so the whole audio file has to get broken up into pieces. So what I did is I separated it within 10 seconds, so it'll send 10 seconds of audio data into the function instead of the entire audio file, as it will most likely exceed 10 megabytes. This way we ensure we get an entire complete transcription. The R declared there is the actual speech recognition object that we'll use to generate the transcript, and the start and end variables are going to be used as the timestamps for the transcription. So the actual transcription is done within this for loop. I have it doing it essentially twice because the results array there will store just an entire string of the entire transcript with no timestamp, so I can use that to generate the metadata. It's like summary tags. And I have just a for loop looping through every 10 seconds, and I also add timestamps to a text file, which will add 10-second intervals, so each line will be 10 seconds, and it's all saved to a file. So here's an example of what a generated text transcription text file looks like. I fed it a news article of a family who lost their father due to COVID-19, and it was talking about how everyone should get vaccinated. But here is example of what it would look like. And finally, we need to generate metadata tags. So here I'd use the Python package TextBrain, which is most likely going to be the best Python package for extracting keywords from a batch of text. So within that same transcription from the last slide, the keywords there are Lane, Evan, and vaccinated. Those are the most common, the most frequent words that were said in the video.
And so we move on with the next subsystem, which is presented by Alejandro Suarez, which is the image OCR processing. OCR, which stands for Optical Character Recognition. It is a technology that recognizes text within a digital image. So we have case one and case two. We will see both. Case two is a derivative of case one. But to get started for case one, we will have an image in format PNG or JPEG, and it will be fed into the Tesseract algorithm, which is open source and it is our main source for this subsystem, and it will be powered by the PyTesseract library, which was created and it's held in Python. The context in words of such pictures will get translated into words, which will become our output, which then the text will be saved in the database with the name of the original picture for an easy access. We also have case two, in which the user does not have the desired format of PNG or JPEG and could be able to feed a PDF, and we will have within that algorithm the chance to translate the PDF into an image format, have them save it on a folder, and then from then they can feed such image, which has been translated from the PDF into the program. And then it will just follow the steps from option number one. Here we have the main installation within a Python powered program or server. We just go ahead and install the library of Tesseract, and we do it by the same way we would create a virtual environment using the PIP. We would first download and install the app, get all the packages in, and then we would just simply install PyTesseract, which is basically Tesseract with all the packages already combined. Next up, we have a test of our program. Here's a picture that will be fed to the algorithm. We can see that the background of the picture is white. We can see that most letters are in black, but we have the ham in pink. Same with the pig. So this will be the picture we will be feeding to the algorithm, so you can go back and forth to see where the deficiencies of this program are. And here's the main algorithm. After you install PyTesseract, you will import all the following libraries. This will be all trying to be inside our algorithm. So we will just ask the user for to choose a file. Once that file is chosen, it will be saved into the extract information function, and then from there we can see the pytesseract.image toString. That's where the algorithm comes into play, and it will look into the source of the file, which is the CRDO dot JPG, and then from there we will extract such information. You can see the output is my name is Alexander Ilton. It has a problem with the pink words and letters. And in case we have a case number two, we will have a separate part of the subsystem, which will be able to quickly transform the PDF into a JPEG or a JPG so that it can be fed into the normal Tesseract algorithm.